All right, let's go ahead and talk about a principle we call herd immunity. So you might have heard about this during the COVID pandemic. You might have heard about it in regards to pertussis and the newest outbreak of measles. But essentially what we're thinking about is if we're able to immunize a certain portion of the population, then we can protect those people that cannot be immunized. So you might ask yourself, who cannot get vaccines? So certain individuals with immunodeficiencies. Of course, babies aren't going to be exposed to every single vaccine just straight out of the womb. So there is a certain amount of time that they generally wait to introduce particular vaccines. And certainly some of our older generations just don't tolerate vaccines very well or are immunocompromised. So essentially what we have here is what proportion of the population do we need to have immunized so that we protect those people that are, I'm going to say weak, but are not able to get immunized. So let's take a look at our figure. So the top figure shows us in blue. These are the not immunized but still healthy. And then in yellow, we're going to see immunized and healthy. And then in red, not immunized, sick, and contagious. So essentially what we have in the first figure is we don't have anyone immunized. So we could think about this being early on in the spread of smallpox. So if you have two individuals that are sick and contagious, then take a look. A good portion of the population is going to get the disease. So out of all those people there, we have just a small amount of them who weren't immunized to begin with, but they stay healthy. So something in their immune system fights it off, or maybe they weren't exposed to a very high viral or bacterial load, so they stayed healthy. If we take a look at the middle pane there, or window or picture, we see that, okay, so we have a small amount of the population that are immunized and healthy. And then we have a couple of people who are not immunized and sick and contagious. And we see that over time, then a good portion of the population is going to come down and be sick and contagious with that particular disease. So the people who are protected were those who were immunized and healthy, and those from the original figure that didn't get sick to begin with and stayed healthy. So in the last figure there, we see, okay, if we increase the amount of individuals in a population that we immunize, then we're going to have just a few people who might become sick, but essentially that sickness is not able to spread because we have so many people who are going to be immunized and healthy. So if I were exposed to the sick person, I'm not going to become sick and I'm not going to become contagious. So essentially what we've done is we've protected more people in the population, particularly thinking about those individuals that cannot get the virus or cannot get the vaccine, so that we can protect the herd. All right, let's take a look at what we call R naught. R naught tells us essentially the number of people that one infected person could infect in a population. So with mumps, one person that's infected can pass it on to 4 to 7 people. You see polio, about the same, smallpox, diphtheria, rubella. Pertussis, we see that that number increases dramatically. So one infected person can infect 12 to 17 other people. And measles, about that much as well. So the threshold tells us essentially what percentage of the population do we need to have vaccinated to protect the herd. So for mumps, we need 75 to 86% of the population to have been vaccinated so that that one infected person is not going to be able to infect those 4 to 7 people. So if you have numerous individuals around you that are vaccinated, then if you yourself are infectious, you're less likely to pass it on because other people are going to be immune to that. So you see the percent of the population that needs to be vaccinated increases as our R naught increases. So for pertussis and measles, we need, upwards of 94% of the population to be vaccinated. Now, for various COVID variants, there's different levels of course, R naught values. So the Omicron variant, for every one infected person, the R naught was 9. For the Delta variant, it was about, we needed to have about 80% of the population to be inoculated to protect us. It just really depends on the particular strains. So I hope that you find this particular figure informative. And I think that's it for this slideshow. See you next week.